Hi everyone, welcome to my video in the Mathematics Essentials series on interval notation. Interval notation. I've been writing with a real pen for some time. I haven't used a Surface pen for a while, so you'll have to excuse my handwriting with the Surface pen. So interval notation, what is it? Well, it's really just another way of writing sets that are intervals in the real numbers. Okay, so if you imagine a real number line, okay, so here's the real number line, and these arrows on the endpoints just indicate that it stretches on forever in either direction, so towards negative infinity on the left and positive infinity on the right. And remember that the set of real numbers was indicated by that notation, the bold R. Okay, let's just say we wanted to take a portion of it. Okay, just this little segment of the real numbers here. Well, that would be an interval in the real numbers. Okay, so they're quite important for other topics in mathematics, particularly calculus and mathematical analysis. If you are going to go on to other topics in mathematics, you will be seeing them every now and again. They are indispensable, really. So let's make a few observations. Okay, so the real numbers are ordered. Okay. Now, there's a more precise mathematical way of saying what it is for a set to be ordered. We aren't going to delve into that much in this series, but we'll note now that it means that if you've got two real numbers, it makes sense to talk about one being smaller than the other or one being bigger than the other. Okay, we all have an intuitive understanding of what it means for things to be ordered according to some kind of relation. And in this case, when we are talking about the real numbers being ordered, we are talking about their place in a list or their size, their magnitude. Okay, so if you just imagine two real numbers, let's say A and B, okay, one of three things is going to happen. Either A will be the bigger one, or A will be the smaller one, okay? That's the same thing as saying B will be the smaller one, or B will be the larger one, okay? Or they're just both the same numbers. So either A is bigger than B, okay? B is bigger than A, or they just come down to the same thing. All right, consider two people and imagine that you wanted to order them from left to right according to their height, how tall they are. Well, either one will be taller than the other, or they'll be the same height. So A will be the taller one, or B will be the taller one, or A and B will be as tall as each other. Their height will be equal. Okay, so that's intuitively what I mean when I say that the real numbers are ordered. Okay, so a subset of the real numbers, okay, can be written or it can be represented graphically on a number line, or using set notation, or using interval notation. Okay, so a subset of, and I should say consecutive. Okay, we need them to be consecutive, which means all numbers in the interval come after another. So we don't have some numbers that are consecutive and then we skip a few. So we don't go from 3.9 to Okay, so the real numbers have these infinitely long, or some of them have infinitely long trailing decimal expansions. Well, any real number can be written with an infinitely long trailing decimal expansion. If you just take 4, okay, you could put infinitely many zeros on the end of it after the decimal point. But you can't say have a real number, then skip some of the real numbers that come after it, and then start again and treat this all as the same interval. Okay, so that's what I mean by them being consecutive. Okay, a subset of consecutive real numbers can be represented graphically on a number line or with set notation, which was the subject of one of my earlier videos, or using interval notation, and that's the subject of this video. Okay, so let's consider a set, specifically the set of all x in the real numbers, or real numbers x, such that it's between a and b, or equal to a and b. Okay, so all of these x's are going to be between a and b, including a and b. Okay, all right, that can be written using set notation like this: set of all x in the real numbers, such that, okay, you'll recall this symbol from an earlier video, a is less than or equal to x, which is less than or equal to b, okay, can be represented as follows. Okay, imagine we have a real number line, okay, and we just put these arrows on either side, okay, because it stretches on indefinitely. Okay, here's A and here's B. So we're taking A to be the smaller one, so the left-hand side of the endpoint of the interval, and B to be the right-hand side of the endpoint of the interval. Okay, we would represent this by drawing a line between them. Okay, and then we would draw a circle at either endpoint. Now, because this interval includes the endpoints, it includes A and B, we indicate that by shading it in. Okay, so this is typically what you will see in a textbook where it's, computer font. Okay, but often in handwriting, people write it like this. If they wanted to represent an interval of this form on a number line, okay, they typically write, so there would be one endpoint of the interval, and there would be another endpoint of the interval. Okay, they put the circles up here, okay, and they connect them to say that they're including every real number and the endpoints, and that's indicated by shading in these circles. Okay, So this is what you'll typically see in a textbook. I'm going to start doing this for the rest of the video. Okay? Now, this set here just means the same thing as what I've indicated graphically on this real number line, right? So we've indicated it graphically. We've also indicated it with set notation. Okay? In interval notation, it would be written like this. And you can see that this notation is much more simple and compact. Okay, it's very useful because, well, mathematicians are lazy, okay? They want to pack as much information into as few symbols as possible, okay? So if there's a shorter way of writing something, they'll typically opt for the shorter way, okay? So that's why there's so much compact notation in mathematics that really means a whole lot more than the number of symbols would perhaps suggest. Okay, so this is the closed interval from A to B. Okay, so this here, that's the closed interval of consecutive real numbers from A to B. Okay, and that it's closed is indicated by these rectangular looking brackets, okay? These square looking brackets on either side. Okay, so that's a consecutive set of real numbers. And what do I mean by closed? I mean that it includes the endpoints. Okay, these circles on the graphical representation of the interval are filled in. Okay, so let's consider another interval, and we'll work with the same kind of form, an interval from A to B. Okay, and this one's going to be an open interval. So here, okay, the set of all x in the real numbers, okay, or the set of all real numbers x, such that A is strictly less than x, which is strictly less than B. Okay? Written in set notation, like this. Okay, the set of all x in the reals, such that A strictly less than x, which is strictly less than B, excuse me, is represented as follows. Graphically, I mean. So here would be our real number line. Okay. And being ordered, we can put one towards the smaller end of the real numbers and one towards the larger end, so left and right. And this is an open interval. So we would draw these circles at A and B, and we would connect them like this. Okay, and now you see here, because these are strict inequalities, so A is strictly less than X, which is strictly less than B, we don't shade in those green circles at the endpoints of A and B. Okay, we leave them open. Okay, so this is an open interval. Okay, and in interval notation, that is written like this. Okay, so that's the interval notation, right? And this here is the open interval from A to B. Okay, so the openness of the interval is indicated by these curved brackets here. Okay, but intervals don't need to be wholly closed and wholly open. You can have combinations. So let's look at an example, and we're going to stick with this form. Okay, so do two examples in one go. So the sets, so here's the first one, set of all x in the real numbers such that a is less than or equal to x, but strictly less than b. So this interval is going to include the left-hand endpoint a, but it's going to exclude the right-hand endpoint b. And we'll close by adding the right-hand set bracket. Okay, so there's this set and this other set, which is a set of all real numbers such that this thing's just going to be the other way around. So a is strictly less than x, which is less than or equal to b. Okay. Represented graphically. Yeah, I'm really trying to get the hang of Surface Pen handwriting. Okay, represented this here. This was horrible. Okay, represented graphically like this. Okay, so call that one star and O plus, circle plus. Okay. I'm not introducing technical terms here. Okay, that's just my way of telling you which one I'm talking about. So this one is represented like this. Okay. First, put down A and B, whatever they happen to be. All right, draw a circle at each of the endpoints. All right, connect the lines because you know you're going to include all of the consecutive real numbers between these endpoints. The only question is whether you are going to include any of the endpoints, and if so, which one. And you'll see that in this first set, which I indicated with the asterisk, it says that a is less than or equal to x. So x could equal a. So, okay, we are including a in the interval, but notice here how it says that x is strictly less than b. Okay, so we're not including b, so we leave that circle at b unfilled in. Okay, we don't fill that one in. All right, so here is the one that I denoted by O plus, so this one here. Okay, this is really going to be just the other way around. Okay, so this is straightforward, nothing too tricky. Okay, math always seems very simple after you've learned it and internalized it. Okay, so here we've drawn our circles at the endpoints A and B. We might as well connect the lines because we know we have to include every consecutive real number between A and B. Our question is just whether we are going to include any of the endpoints, and if so, which endpoint are we going to include? Well, you can see that A is strictly less than X. Okay, so whatever X we happen to be talking about, it's going to be bigger than A. It can't be equal to A. Okay, it could be less than B, but it could also be equal to b. So we will shade in the right-hand endpoint of the interval b. Okay? So, as I was saying, intervals don't have to be wholly closed or wholly open. They don't have to be closed or open. They can be half open or half closed. Okay, so this one here on the left, this one is half open. Okay, so we're including a, this is it, this is the interval denoted by interval notation, we're including a, so on the left-hand side we have a square bracket, but we aren't including b, so we write a curved bracket on the right-hand side. Okay, and this one is half open. Okay, whenever you see an interval that uses different kinds of brackets, it's going to be a half something, okay? It's either going to be half open or half closed. How do you remember which one is which? Well, it's always the right-hand side. You look at this one, okay? And if that's an open bracket, a curved bracket, it's half open, okay? If it was a closed, if it was a more rectangular looking bracket, like the one on the left here, it would be a half closed bracket, so long as the left-hand one wasn't a closed bracket as well. So it would be a half closed interval. Okay, this one here is half open, interval from A to B. Okay, now this one here, the one that I represented by O plus, okay, this one is going to be the half, what do you think, closed or open? Okay, it's going to be the half closed interval from A to B. Okay, you just notice that both kinds of brackets are being used, and you just look at the right-hand bracket. And you ask yourself, is that open interval notation or closed interval notation? So it's going to be half closed, because the right-hand bracket is the kind of brackets you used for closed intervals. Okay, so this is the half closed interval from A to B. Okay, so before we wrap up, I'll say something very important about intervals so you don't get yourself into trouble. Infinity, oh, I'm going to write that again. Okay, infinity, it's cold where I am, so my hands are shaking. Infinity is not a real number. Okay, this is very important to remember when you are writing interval notation. Okay, because what do these intervals over the real numbers include? They include real numbers. Okay, so you can never write an interval in interval notation that includes infinity. All right, nevertheless, we do use the symbol for infinity to describe intervals of real numbers that extend forever. They just keep going indefinitely. All right, so I'll do some examples, and maybe I'll write all of them graphically, maybe not, maybe I'll leave some for you to think about, but let's consider this one. I'll write it in set notation first. Okay, so the set of all x in the real numbers such that x is greater than or equal to a. Okay, so I'll do this one on a number line. Keep it nice and small. Okay, so this one doesn't refer to any other real number. In other words, there's not a b like we did with all our previous examples. Okay, there's just one real number. Okay, and well, I mean, there's infinitely many real numbers in this interval, but you know, only one arbitrary real number is referred to in terms of endpoints. I mean, so let's put a anywhere. Okay, and this set here, okay, is just all of the real numbers bigger than a, including a. So how would we denote this graphically? Well, we just draw the circle, okay. But unlike before, we had another real number to connect it to. We don't now, because this one just includes all of the real numbers bigger than a. We know it includes a as well, so we should shade that circle in. but there's nothing to connect it to. So we just draw this line and indicate with an arrow that it just extends forever in the direction of positive infinity. So another set, actually in interval notation, this would be written like this, okay? We're including A, but we use the symbol for infinity to indicate that it stretches on forever. So don't misunderstand what this means. It doesn't mean that, you know, it's a discrete or finite interval that starts at A and ends somewhere. That's not what we're saying. So this here isn't really an end point, unlike our previous examples, and we can't include it because we can only include real numbers, and infinity is not a real number. So we put a curved bracket on the right-hand side. And notice I didn't say right-hand endpoint because it doesn't end, so it's not an endpoint. Okay, so whenever you use the symbol for infinity, it's always going to be coupled with a curved bracket. So you will never see anything like this on the left-hand side or anything like this on the right-hand side. It just doesn't make sense. Okay? So here's another example. Do the set of all x in the real numbers such that x is less than or equal to a. Okay? And in interval notation, actually I'll do it graphically first because that's better for getting intuitions about what's going on. It's much easier to understand what's going on when we think graphically and geometrically and think in terms of diagrams rather than symbology, right? So let's put A down like we have every time. Okay, there's no B here. All right, we'll draw our circle above A. We know it includes A, so we might as well fill it in, okay, because it's the set of all real numbers x that are less than or equal to A. Okay, but which direction do we go? Well, we go in the direction of real numbers less than A. We don't connect to any other real number because it's not a closed interval. And it extends forever, so we know that in interval notation this is going to make use of the symbol for infinity. All right, so that's how we would write that one. And in interval, or that's how we would represent it graphically. In interval notation, it's like this. So negative infinity to A, and we're including A. Okay, 2 more examples. And maybe I'll leave them for you to think about. Actually, they're pretty straightforward, so I'll just do them. So the set of all x in the real numbers such that x is strictly greater than a. Okay, we'll do the interval notation first this time. So that's from a not inclusive because it's a strict inequality. X is strictly greater than a. So all of the real numbers in this interval are just going to be all of the real numbers that are bigger than a, whatever a happens to be in the end. Okay, and that goes on towards infinity, just stretches on indefinitely. Okay, last example is the set of all x in the real numbers such that x is strictly less than a, and that in interval notation would be written like this. Okay, so all of the real numbers that are smaller than a. Okay, so let's do both of them graphically. Okay, so here's first one, and here's our second one. Okay, so these are real number lines, and we're going to denote these intervals on them. Let's put down A. So here's A, draw a circle above it. Do we shade in the circle? No, because this here is a strict inequality. Okay, and we can see here we've got a curved bracket, so we're not going to include A. Okay, and we're including all of the real numbers that are bigger than A. So that just means, whoops, that just means our interval is going to be represented like this. Okay, and it's just in the other direction for this interval. So we'll put down A, we'll write our circle above it. We won't shade it in because that is a strict inequality, so it's all of the real numbers strictly less than A. And we see here that on the right-hand side endpoint for the interval, it's a curved bracket, so that tells us that A is not included in the interval. So we represent that like this. This green line is just denoting all of the real numbers strictly less than A. So that's interval notation. Yeah, so just to recap, so the real numbers are ordered. That means it makes sense to talk about one real number being bigger than or smaller than another real number, okay? So for any two real numbers, one of them's got to be bigger, okay, which is the same thing as saying that the other one is smaller, or they're the same real number, which is to say that they're equal, okay? Remember, the real numbers that we represent in these intervals are consecutive, okay? So a subset of consecutive real numbers can be represented graphically on a number line, or with set notation, or using interval notation, okay? So really, they are just fancy sets, and that's made obvious by the fact that we can write them entirely in set notation, okay? And infinity is not a real number, because remember, what do we include in intervals? We include real numbers, okay? Well, if infinity isn't a real number, it's not the kind of thing that can be included in an interval over the real numbers. Nonetheless, we still use the symbol for infinity to indicate that an interval stretches on forever, okay? It just extends forever in some direction, either towards the positive end of the real number line or the negative end of the real number line. And we use positive infinity and negative infinity, respectively, to indicate this fact. So that's interval notation in a nutshell. The next video will be on absolute value. I do respond to comments, and if you have a question about interval notation, feel free to post it in the comments. So that's all for now. Until the next video, bye for now.